Well, I said on the last video that I wasn't going to do any work on July 4th, but with my new job at work now, I have all holidays and weekends off. I may have mentioned that before. So today turned out to be a very hot, lazy 4th of July. I was over at my sister-in-law's for a wonderful lunch with family, and now I'm home in the air conditioning and decided to do some work. So what you see here in front of you are the 3 test probes that you put together for the K2 for doing some various testing on the radio. I mentioned I'm going to try to do all the testing that I can with the radio itself and not use my own equipment. They include all of this with the kit. This is a simple wire that becomes your voltage probe to check voltages, and I'll show you that in use. This is the counter. Yeah, I had to think about it. Frequency counter probe. This has a 10 puff capacitor in here under shrink wrap, and it's just a small, very thin coax to a probe tip, and that plugs into the radio itself. All of these connectors plug into the radio. This one is the RF probe, which they include with the kit. It's a little circuit board. You use this as the circuit board as a spacer too for an earlier part of the build. And then you build this out of it, and they include all the components. Everything you see here is included. And the 2 banana plugs plug into a digital multimeter, and you use it as an RF probe. I have not used that yet. So what I'm going to do is, starting with the voltage thing, we're going to run through with the thing in the book on that, and then we're going to run through the thing on the book, on the counter probe. I have to confess, I have used the voltage probe already off camera. I did that part, but I'm going to just show it to you on camera again. I'll be right back. So what you're looking at is the upper corner of the front control board, the back of it. Let me try autofocus. I apologize for this not being in focus. It just doesn't want to do it. It keeps wanting to focus on the table. I don't know. Anyway, let me just show you. There's a little connector here and a little connector here. There's 2 of them. This connector has a jumper on it, this black thing. You can put it on one side or the other of these pins. And that controls whether or not your voltage readings go to the radio itself or to the probe. This is where the probe plugs in. So the probe is just that green wire, and it is literally nothing more than a wire. Plugs in like that. And following the book, it says then you take the jumper off and move it toward P5. So the jumper comes off. You see there's 3 pins, and you put it on this side. And now the reading for the voltage will go from the probe to the LCD screen instead of to my power supply to the LCD screen. That's how that goes. Let me zoom back out again. Okay, so I'm going to power on the power supply, and we'll power up the radio, and we're on the frequency. So we hit the display button, and that takes you to the voltage display. And if you recall on the video I did yesterday, the voltage here showed how much my power supply had, which was 13.6 volts, I believe. It's reading 0, which is correct, because it's now reading whatever I touch the end of this wire to. So the test the radio they want you to do is to touch it to pin 1 of the I/O controller, which is U1 on the RF board, and the voltage will appear on here. Now if I'll quickly, pin 1, this IC chip here is U1, and pin 1 is the one to the left on the lower. I have to put this down so you can see the screen. And I'm going to touch the wire to pin 1. And you see we got 5.9 volts. The book says 6. 5.9 is good for me. I'm happy with that. So it's working. This is merely a test to see if this stuff's working, so later on in the build you use this for various things in the radio. So now we'll put, I took that off, I'll take the little jumper and put it back. And now we're reading the power off my power supply, which is 13.4 volts. There you go. Okay, next we're going to check the counter. Now that one, I have to, as I said, I did that one before already. I have not used this yet. I built it, but haven't used it. I'm going to read the book and do exactly what the book says on camera. And I will be right back. Okay, we're back. So this part of this, I'm gonna follow the book and do this on camera, so bear with me. Plug the frequency counter probe into P6, which is at the far left of the control board, as viewed from the front of the transceiver. The connector can only be plugged in one way, so that's going to be on the back of this board. Actually, let me go that way. So it says counter. I know you can't read it, and I'm not going to bother zooming in. It won't focus anyway. There's another one of these connectors in that corner. It says counter, and I'm going to plug this into it. Okay. We're plugged in. By the way, this seems short, but that's how long they told you to make it. It said cut it 7 inches, and that's what I did. I assume it's long enough to reach whatever it wants me to test in here. Turn on the K2 and tap menu. To bring up the menu, then scroll to the Cal menu, entry. So that's the tap menu. I gotta remember how to do this. Hold edit. Now wait a minute. Well, I'm doing it on camera, so I have to figure this out. Bring up menu to bring, tap menu to bring up the menu, then scroll to the Cal menu entry. Okay. Scroll. Cal off. Hold edit. So now it moved the dots over to here. And now you have different settings. And I'm changing this to... These are all various functions of the test equipment. I'm looking for FCTR. That's a T. Strange looking T, but it's lowercase. Hold edit again to activate the frequency counter of the calc submenu. Hold edit again. Now we got all zeros. So now this is the frequency counter output. To test the counter, you can read the frequency of 4 MHz oscillator on the control board. Touch the counter probe tip to the left side of trimmer capacitor C22, which is just below U1, the microcontroller. The LCD should now read within plus or minus 0.02 kilohertz of 4,000, or 4 megahertz, 4,000 kilohertz. So U1 is the same thing. I'm going to have to keep this up while I touch it. We're going to... What pin was that again? Left side of trimmer cap UC of C22, which is just below U1. Oh, control board. This is the RF board. Yeah, that makes sense. All right, there it is. It's this. I know you can't see it. there's a little tiny trimmer cap way under there below U1. I'm going to touch the left side. And do that while I'm facing forward and see this. Yeah, good luck. I hit the button too and I lost my menu. Alright, let's try this. Cal off. FCTR. Back to the zeros. I'm going to move this up. Because I got to look behind it. Yeah. I think it's possible the oscillator's not running. Oh, there we go. 39999.98. Man, okay, now I figured it out. You know what I was doing? The left side of the capacitor, if you're looking at the front of the radio, if you're looking at the back of the radio, it's the right side. It probably said that and I missed it. There it goes, 399. That's almost 4,000. Very good. So it's working. The oscillator's running. The probe works. Let's read the next part here. Remove. Oh, the next thing is to do the audio amplifier tone generator test. Oh, I need a speaker for that. Okay, I'm going to stop here. Figure out if I have a speaker to do this with, and I'll be back. Alright, we're going to give this a go. I don't know if this will work. I have this little cheap speaker. I plugged it into the headphone jack. It says in the book to use a low impedance 4 to 32 ohm headphone set, which I want to do it on camera, so we're going to see if it'll drive the speaker, hopefully. I don't know. We'll find out. Okay. Tap menu and scroll to the side tone level menu entry. Okay, tap menu. Side tone is STL. STL, yep. Hold edit to activate the side tone. You should now hear a clean 600 Hertz tone. Tuning the VFO should vary the volume. Well, let's see if that works. Oh yeah. It's not very loud. And the volume doesn't affect it. I'm going to hold it up to the mic. It's hanging above me. You should be able to hear that now. And we're going to change the tone. Interesting. It's actually changing the volume more than a tone. But that's your side tone for Morse code for CW. But it's working. Maybe it would be different if I had headphones on, I'm sure. This is a long audio cable I have plugged into this, and it's also a long, I'm not sure the ohms on the speaker. So, but it's working. Notice that turning the AF gain control does not affect the volume. Yeah, we tried that. The side tone is injected into the AF amplifier after the volume control. So AF gain affects only the receiver volume. Tap the menu to turn off the side tone. And it did turn off. Then scroll up to the side tone pitch entry, STP, which is there. Tap the band switch. The display will now show STP 0.60, and yes it does. This indicates the side tone pitch is set for 0.6 kilohertz or 600 hertz. hold the edit to turn on the side tone. And you can hear it again. I'll hold it up to the mic. Then vary the VFO. The pitch will change. Oh yeah. It goes up to 800. And it goes down to 400 hertz. And we'll go back to 6. Tap the menu. Turn it off. In the following step, you will test the keyer, the audio tone generator only. This tests the keyer jack, speed control, and potentiometer read circuits. Do I need a key for this? I have one, but I don't have it hooked up. No, I don't think I need anything. Let's just try this. See what happens. Tap the mode until C is displayed. I think I got to get out of the menu. Okay. Tap mode until C is displayed. Alright, that's this little thing here next to the frequency is U is upper sideband, C is CW, L is lower sideband. So we're on C. Plug a keyer paddle, that's what I said, into the key jack. Hang on. I do have a key. Paddle, actually. It's a Kent paddle. And no, I don't know CW very well. I'm still learning, but here we go. We're just going to see if it works. Into the key jack. The plug must be stereo, 2-circuit it is. A mono plug will key the transmitter continuously. Yeah, okay. I believe that is on the back corner. Yeah. So this plugs in back here, back where my finger is. Plugging that in. Okay. Using the menu INP entry, set up the keyer input for either paddle N or paddle R as described previously. Yeah. So we got to go to menu. We go to INP. Hand. I think I want right. I'm not sure, but let's try R. And then we hit menu again to activate it. Adjust the keyer control. As soon as you turn it, the display should show the keying speed. Yeah, there it is. That's the speed. It's words per minute. It's got a built-in keyer. So let's go to 20. It goes 9 to 50 words per minute. While listening with headphones, I have my speaker. Test the keyer paddle to verify it's working. Hear that? That's the DITS. The dash is not working. Now that might be because of the setting. Let me go back to this. Let's try N. Whoops. There we go. So it's sending Morse code. I'm not doing anything. I'm just randomly tapping it. But we have dots and dits. That's it. Alright, we're good. And I'll read the next section and be back. Okay, I'm back. I think I'm set up for this properly. The next step is to set the AGC threshold. I'm going to use my voltmeter, which you can see in the shot. And I'm going to read the directions and do it. I didn't do it yet, but I did look at the board to make sure I know what I'm doing, so I'm not fumbling while I'm on camera here trying to figure out what I'm doing. So I read ahead a little bit. Make sure RF gain control is rotated fully clockwise. RF gain, yep. Locate potential R1, that's on the back of the control board. I found that. Set your DMM for DC volts. We did that. Connect negative to the ground jumper or to the K2 chassis ground. And we're gonna, I zeroed the probe. I'm gonna go right up. There's a ground jumper right on top here. The control board, by the way, is the board back here. And I'm going to turn the radio to do this anyway. You'll see it. All right, we did that. Flip the page. I'm going to have to move this. Let me do this. Get rid of the glare. Okay. Touch the positive lead to pin 5 of U2 on the control board. U2 is located above trimmer pot R1. Pin 5 is the pin nearest diode D1. Adjust R1 for a rating of 3.80 volts on your digital multimeter. This is the suggested setting, but it can be adjusted later to suit the operator at your automatic gain control. If you cannot set the voltage to 3.8, turn the AGC level application, turn to the note included with your kit, and follow the instructions to add the 15K resistor to the control board. Hopefully I don't have to do that. An extra 15K is included in your K2 kit for this purpose. Okay, so we're going to turn this on. I'm going to tip this up. And bring it around. So unfortunately where my ground is connected is slightly in my way. Let's move that. Alright, the ground is connected. We can see that in the shot. I know we're not going to be focused. This blue little thing you can see on camera is the potentiometer that you turn. U2 is the IC just above it. And I'm going to go ahead and touch pin 5 from on this side. And we have 3, now we have 8? Wow. 8.31. That's pretty high. I hope I can adjust it that much. Huh? Where's the diode that's talking about? U2. Yeah. Pin 5 is nearest diode D1. Yeah, there's the diode. Oh, I was on pin 10. 2.8 volts. That's more like it. 1, 2, 3, 4, 5. Yeah, I was on pin 10. I was looking at it backwards. Okay, the diode's there. This is pin 5. Let me get that balanced in there because I have to use my other hand to turn the potentiometer. I have a screwdriver ready. And let's see. Yeah, that screwdriver is not going to work. Let me try this other one. It's too pointy. It doesn't catch the slot. Wow, that's jumped right up. 3.8 we want. Almost there. Just hold it for a minute and make sure it's settled. 3.8 volts. Okay, the AGC is set. I'm going to keep the camera rolling and simply read the next section. The S meter must be realigned anytime the AGC threshold is changed, so S meter realignment is covered in the following steps. Using the menu, select KLSLO for S meter 0. Okay, menu. KL. That's the other KL though. SLO. Oh no, now I remember. Tap it. Oh no. Hold it. And we want SLO. Tap it. Turn the VFO until you see only the leftmost segment of the LED bar graph lit. Wait a minute. Hold edit a second time to activate it. Let me, man, I keep doing that. Alright, now it's turned on. Turn the VFO knob until you see only the leftmost segment of the LED bar graph lit. Then turn the knob a bit more clockwise until it just turns off. I assume they're meaning the S meter up here, the LED. It's not coming on. There it is. Right there. Okay. Then turn the knob a bit more clockwise until it is just off. A bit more. Does it want it over there? Or over here? To me, it starts here and goes this way. So there's two settings. There's a low setting and a high setting. Sorry, I'm reading on camera. I'm trying to figure this out. Turn the VFO knob until you see only the leftmost segment lit. Alright, that's where I screwed up. I gotta go all the way till we go to the left, till it's lit. Then turn the knob a bit more clockwise until it just turns off. 166 is off, 165 is on. Right there. Exit the function by tapping menu. Okay. Enter the menu again and select KLS high. High. And we hold it down to activate it. Now it's active. Turn the full RF gain fully counterclockwise. RF gain was up before. Oh, that was slightly off. Maybe I should redo the other one. This knob was not fully clockwise. I think it was supposed to be. Let me go back. Let's do the low. Activate it. RF gain is high. Yeah, it did change. Now it's 162 on and 163 is off because the RF gain was supposed to be maxed. Okay, so now let's get out of that. And now we go to the high. Okay. Now we go RF gain fully counterclockwise. Adjust the VFO knob until bar graph segment 9 lights, which is that one. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, that's 10. Right? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, no, 9. 9. Then turn it a bit more counterclockwise until segment 10 just lights. Okay. $25 is 9. 24 is 10. Turn the RF gain control back to its full clockwise position. Exit the Cal S high function by tapping menu. I wonder if that should be lit though. Shouldn't that be off if we're in the low section? Let me redo the low one. Yeah. It's supposed to be off. I get it now. Fully clockwise it should be off. Fully counterclockwise it should be the other one. Right. That. Exit. Let's do high again. Fully this way. 9. 25, 24, 24. Yeah, it goes off. That's what it's supposed to do. There. Okay, that is set. After you've completed the assembly, the S meter can be further calibrated for an S9 reading with a 50 what would that be? Microvolt signal level if you have an Elecraft K or a test oscillator or a calibrated signal source. I do have a very good signal source. I have an HP signal generator. I will do that at a later date. I just want to finish these basic settings. There's one more test here, and then we go on to the next assembly section, which is adding more parts. So I want to finish this up. This is just verifying that everything up to that point works. Next thing and the last thing is the bar graph current test. So we're going to do that on camera. I'm just going to keep the camera rolling. In the following step, you will test the current measurement circuit by using the bar graphed LEDs to establish a known current drain. Enter the menu and verify that graphed LED bar graph mode is set to dot, not to bar or off. Okay, enter the menu. And we want to go to graph. Graph. It is set to dot. Verify that it is set to dot, not to bar or off. It is indeed set to dot. Okay. Set the RF gain control for minimum gain. Segment 10 of the LED bar graph should now be on if you've done the S meter described above. Set the RF gain to where? For minimum gain, segment 10 should now be on. Segment 10. Yep, all the way to the left. That is correct. Using the menu, select the LCD menu entry. Right there. Change the parameter from night to day. Oh yeah, look at that. It changes the... It dims this screen and brightens this. That's cool. At this point, you will see the LCD backlight turn off and the segment 10 of the LED will become brighter. Exit the menu and tap Display. Tap Display to switch to voltage current mode. Right? Write down the voltage and current readings. I'm going to write them right in the book here. They're no different. Oh, you know what? My voltage is slightly lower because of the current draw. So it's 13.4 and it's I 0.06. Use the menu to change the graph mode to bar. All 10 segments of the LED should now be on. Alright. We get out of here. We go to graph. Nope. Go to bar. They're all lit. Exit the menu and check the current. Oh yeah, it changed. It should now be about 0.16 or 0.18 amps higher. It is. It's 0.20 and we had before a 0.06, so it's actually 0.14 higher. It's actually a little bit low because it said it should be between 0.16 and 0.18. It's 0.14 by my math. I don't think that's a big deal though. Right? Use the menu to change the graph to dot. Dot. And LCD to night. The combination of LCD, day, and graph bar can result in high peak current drain on receive. Dot or off are preferred for battery operation. See advanced operating features. Okay. That's it. We're up to assembly. So I verified everything works up to that point. The next thing, and I'm not making videos of it. Wow, look at that glare. How do I get rid of that? Let's see. There we go. You populate that RF board. These are all resistors. There's tons of things to install. I will make another video when I get to something interesting. When I'm going to videotape all the testing that I do, like I have been doing today, and any interesting installation things that I think will be worth videotaping. Otherwise, populating the board with capacitors and resistors, we are not going to make a big deal out of. I do plan on making a video of winding some of the toroids. Not all of them. It's extremely time consuming and tedious. I've done it before. I have built a couple of soft rock receivers, RX-TX and an RX soft rock receiver. They had a bunch of toroids to wind. So I have done it. It's tedious and time consuming, and there's a lot of toroids. So that's it for now. Up until the next part, assembly part 2. That's where we're up to. Thanks for watching, and this is Tom saying 73. Have a great 4th of July.